Hi, my name is Nicholas Espinal. I'm part of Group 8, and I was assigned number 18 for my Chapter 21 quiz, and this is what this question asks. The figure shows two unequal point charges, little q and big Q, of opposite sign, and charge big Q has greater magnitude than charge little q. In which of the regions, x, y, or z, will there be a point at which the net electric field due to these two charges is zero? The correct answer here is region x. Uh, but first, we need to ask ourselves, in order for a net electric field to be zero, what would we need? We would need two electric fields to cancel each other out. So as we can see, section Y is already out of the question because if a point was here, the electric field from the left, if we were to say little q is positive and big Q is negative, this still works in this case for this question. Uh, if the electric field from the left is positive, it's going to be going away to the right. And the electric field from the right, which is negative, is also going to be going to the right. Both of these electric fields are going to the right. And in order for the net electric field to be zero, we would need one to be to the left, but that is not the case in Y. In Y, there is no net zero electric field because of the directions of the electric field. And we already see that. We don't even have to worry about Y. Z, if a point is on this side next to large Q, you'll notice that the electric field is equal to K times the charge over R squared. At large Q, you'll notice that the radius is a lot smaller, which is going to make this electric field large, and the charge is a lot larger, which is also going to make this very large. And in comparison of that electric field to the electric field of little q, which is on the other side, little q is going to have a smaller charge, and it's going to have a larger radius, a larger distance, and that is going to make this electric field a lot smaller. And we could already tell that these two electric fields are not going to be the same. They're going to be need to be equal and opposite in magnitude. Equal in magnitude, opposite in direction. And in this side, we could see that they're not equal in magnitude at all, just mostly because it's right next to the larger charge. This brings us to X, and at this point, we will see that the electric field going to little q is going to be away from little q. The electric field for a positive charge is going to be away from it, while the electric field to larger q, which is negative, it is going to be going towards it. So this reaches our criteria that we need two electric fields that are going in opposite directions. At this point, it is a matter of finding the exact point in region X to see where these two electric fields meet and meet in magnitude, and they're already opposite in direction. So in X is going to lie the point where the net electric field is zero. So that is why the answer to this question is only region X.